When it comes to working in a lab, X marks the relative concentration. So a 50X buffer is 50 times more concentrated than you want to use it at, the 1X working concentration. Which means that you need 50 times less volume of the stock to make the volume of the working solution that you want to make. So if we want to make 1 liter of 1X TAE, then we need to divide 1 liter or 1,000 milliliters by 50, and we get 20. And so when you go and you make your 1X TAE in a minute, Ryan, you're going to take 20 milliliters of the 50X and dilute it up to a liter, and that will give you 1X. If we say start, we can also go the other direction. And so instead of starting with the volume that we want and dividing it by the X factor to get the volume of the stock that we need, we can take the volume of the stock that we have and multiply that by that X factor in order to get the volume we need. So if you say you want to have 20 mils, you have 20 mils of your 50X, then you would do 20 times 50 would give you 1,000, and that's how you know what volume you need to dilute it to. So to go from the volume that you want to the volume of the stock that you need, you divide it by the X factor. To go the other direction, to go from the volume of the stock that you have to the dilute, to the total volume that you're going to end up with, you want to multiply it by it. And so with 50X, we either divide or multiply by 50. And then you'll also see things like this one's 20X. So if we wanted a liter of the 20X, we do 1,000 divided by 20 and we get 50. And so we know we need 50 of this, and then to dilute it to 1 liter with water. By having these more concentrated solutions, you're saving yourself a lot of time, because you can make 50 times more of liters of your working solution than you would have of your 50X solution. And if you have 1,000X, then you make it once and you've got 1,000 times more than you've made. And so instead of having to go and weigh out the solids each time, now you just got to do a simple dilution. We make the solution once, and now we can make 50 times the amount that we make of our actual working solution. So the X factor, remember, so we have this volume, we have a liter. So how many liters of our 1X can we have? 50, exactly. We can make 50 liters just by making this 50X one time. And so in terms of the concentrations too, so we've been talking in terms of volumes, but the concentrations are going to be 50 times lower in our working as they would be in our stock. And so in our tris EDTA, we basically have 2 molars of the tris in our 50X stock, and 2 molar divided by 50, we get 40 millimolars in our working. And then similarly for the other components. And so you can use them for concentrations or volumes, you can do that division. You can also, typically your 1X is your working concentration, but not always. So you can actually, so we're using this TAE for our agarose gels, and you can actually run agarose gels typically at like 0.5X. And so that's a little weird, and sometimes when we have our dyes, we use them at like a more concentrated. But the great thing is that you can just use it with C1V1 equals C2V2. You can use X factors. So you would just plug in, say if you want to go from 50X to 0.5X, you would just plug 50 in as your C1 and 0.5 in as your C2 and use those, and you can math your way through just like you would with normal dilution calculations. And so you can use them that way. You can then easily think things through in the lab. So just remember that you've got to kind of just divide the volume you want, the total volume you want, by the X factor to get the volume of the stock that you need. And to go the other direction, you take the volume of the stock that you have and you multiply that by the X factor to get the volume that you need. And so stock solutions like this are really, really helpful. And what you also notice is that we have like 50X, we have 20X, we have 10X, we have 1,000X. 1,000X is great because when you can do it. So when we had our antibiotics that we were adding to our plate, we had our 1,000X concentration. And so when we had that, when you have 1,000, then you basically go from mils to microliters. And so if you have a liter that you want to add 1,000X to, then it's going to be 1 milliliter, and you can just easily do things in your head that way. We use these nice round numbers because then it's easy to divide and do mental math with. And so some things are really annoying in that they are like 4x or 6x. 4x is okay. The 6x, the 6x dye for the gels is a little annoying. And so you typically then want to choose volumes for your samples that are going to be convenient for you to divide by 6 in. And so that's why you'll see, sometimes I'll use like 6. So if you had 6, that would mean you have 5 of your sample and then 1 of the 6x buffer. And then if you wanted to, you can like double that so that you could do 10 and 2 and 12 and that sort of thing. But what happens when you want to do like 9 and what do I add? So if you have a 6x buffer, that means that for each 6 parts of your total solution, 1 part of that is going to need to be your buffer, and then the 5 parts are going to be your sample. And so now you just need to figure out what's the size of a part. And so you need to divide your sample volume by the x minus 1. So because you're going to have 1 part of this thing be your dye per 6 parts total.
We're going from 6x to 1x, so you know it's a 6 times dilution, so you have 6 parts. 1 part is the dye, and then 5 parts of the sample. So the size of 1 part is then 9 divided by 5 is 1.8. So 5 times 1.8 is the volume of sample you have, and then you add 1.8 microliters of the dye, of the 6x dye, to get it in total then to 1x. And the total volume is then 6 times 1.8.
So if our sample volume was 9, and then we're adding 1.8, we've got 10.8 of our total solution.
Sweet.
And if we have that 10.8 of our total solution, and we were to divide that by 6, we should get 1.8. So if you know the total volume that you want, then you just divide that by the X factor. But if you're starting with the volume of your sample, then you're gonna have to divide that by the X minus 1. So even if it's a kind of gnarly X factor, what you can do is you have a volume that you have of your sample, say, and then you can divide that by your x minus 1. So in this case, 6 minus 1 is 5, so we divide by 5, and that is the size of a part, and then we add that much of our dye, and we get the dye to 1x, and we didn't have to change the volume of our sample. And so, or you could just make your life easier and choose a round number that makes life easier. But anyway, hope that helped, and hope you're now a fan of stock solutions and working concentrations and stock concentrations, and oh my.